another resultant probability which says that when we take the average of our observations so far, that it shouldn't be too far from the expected value of any one experiment, is called the strong law of large numbers. This says, let's let x1, x2, etc. be independent identical trials of an experiment. Let yn be the average of the first n observations, and let's say expected value of any one of these trials is mu. Then the probability that the limit as n goes to infinity of yn equals mu is 1. So this sequence of averages almost certainly approaches mu. Now this implies the weak law of large numbers. Which says that the limit as n goes to infinity of the probability that y differs from the mean by more than epsilon is 0. Now, the two theorems look very similar. You look back and forth and you say, well, they're almost saying the same thing. They're saying that the sample averages are going to get closer and closer to mu. The difference is that the strong law is a probability that a sequence of random variables approaches a number. And the weak law is a sequence of probabilities which approaches 0. So the difference is probability that a sequence converges and versus convergence of a sequence of probabilities. The difference is very subtle and completely theoretical. So it's not something that you could distinguish in practice. So if these look exactly the same to you, don't worry too much about it. They're very, very similar. And I don't think there's any way to use what we've done in this course to really say what the difference is. Another way to summarize what the two theorems are saying is that the expected value of a random variable becomes more and more apparent as you repeat the experiment many times and take the average of all your observations. The end.